Hi, and thank you for tuning in to Gavin Lon Digital. I'm Gavin Lon. In the previous video, we added an administrator account to our system. Please view the previous part of this course, part 15, before viewing this video. In this video, we are going to implement client-side code for a customized login facility where a user can enter the user's credentials in the form of a username and password through a login form displayed within a modal dialog inside the user's browser. Through this login modal dialog, the user can submit the user's entered credentials to the server and subsequently be authenticated by appropriate server-side code, which is code that we'll implement in this video. So we are going to cover a lot of ground and write a lot of code in this tutorial. Please don't be overwhelmed by the amount of code that we will write in this tutorial. Remember, you are able to copy the code from GitHub and paste it into your projects as you follow along with this tutorial if you don't wish to write the code line by line, as will be demonstrated in this tutorial. Please find a link to the relevant GitHub web pages below in the description. I would say it is definitely worth your while to stay with this tutorial right till the end, because this video contains content from which you'll learn about AJAX jQuery, unobtrusive validation, writing jQuery to perform asynchronous operations, implementing your own MVC controller class to handle user authentication, and much more. Please consider subscribing for content like this and much more, and please ring the bell so that you'll be notified of future content. If you like this video, please give it a thumbs up, and please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link below in the description to my Buy Me a Coffee webpage. It will be greatly appreciated. We could use the default login facility provided out of the box with the identity technology. But let's say that our design requirement means that we need to customize our login facility. As mentioned, we are going to create our own login form displayed within a modal dialog. The reason for this requirement may be that we wish to provide a more appropriate login facility in terms of an overall UX design concern. In the previous video of this course, we tested the authentication of our administrator account, which is an account that we manually added to our database. We tested that we were able to log into the system through the use of a login page that is provided to us out of the box, as it were. If we search our project for the Razor view or Razor page that contains the code for the login page that is currently presented to us when we click the appropriate login menu item, we'd end up scratching our heads. We simply wouldn't find the relevant code in our project. Even though when we run the project and click the login menu item, which is part of the main menu, a login page is presented to us. And even though this login page is clearly functional, this page seems to appear like magic. The code for this login page doesn't exist anywhere in our projects. If we go to our projects in Visual Studio and look at the identity area, which has automatically been created for us. This was created when we created our MVC project in Visual Studio. We can see that we only have one Razor view residing in the identity area. There certainly isn't any code for a login page that seems to magically be presented to us when we run the application and click the appropriate login menu item. So where's the code for the login page? From ASP.NET Core version 2.1, the identity-related Razor UI files are shipped in a pre-built package, microsoft.aspnetcore.identity.ui. So if we wanted to have access to the identity Razor UI files, like for example, the login page that we used in the previous video to test logging on to the system as an administrator, all we as developers need to do is reference the microsoft.aspnetcore.identity.ui package from within our projects. This referencing was automatically done for us when we created our project through Visual Studio, because we elected to include the identity technology in our project during the project creation process. Through Visual Studio, we are able to add whichever identity UI template files we wish to override. So we can override the default identity code for user registration, login functionality, two-factor authentication, etc. So to override the default functionality that identity provides, we can add the files we wish to override to our projects. We can then customize the relevant Identity UI template files, which in effect means we can override the default functionality provided to us out of the box by Identity. So if we wanted to provide our own customizations for the login page, we could do this by first adding the relevant login Identity UI template to our project. To do this, we can right-click our project node, select the Add menu item, then New Scaffolded Item. We can select the item labeled Identity and then click the Add button. And look at that, we are presented with a dialog that contains a checked list box. Each item in the checked list box denotes an Identity UI template that we can choose to include within our projects and customize if we choose to do so. So as you can see, we can include the registration Identity UI file template, the login Identity UI file template, an external login Identity UI file template, etc. We can then customize these UI files if we choose to do so, and in effect override the out-of-the-box functionality provided by Identity. So, although we are not going to customize our login facility using the login UI template here, let's check the appropriate checkbox to include the login UI template in our project so that we can take a closer look at the code provided by default in the relevant UI template file. So first of all, note that these UI files are implemented as Razor pages and are not implemented as Razor views. The key difference between a Razor page and a Razor view is that unlike with a Razor view, the model and controller code is included within the Razor page itself. So let's look at the login.cshtml file. Unlike Razor views that MVC developers are used to, Razor pages can include a code behind file. This will be familiar to web forms developers. So if we expand the node denoting the login.cshtml file, we can see that it contains a child node. This is the code behind file, and it contains two public methods, one named onGetAsync, the other named onPostAsync. So you may have already guessed that the onGetAsync method contains code to handle HTTP GET requests, and the onPostAsync method contains code for handling HTTP POST requests. So as stated earlier, we are not going to customize our login facility using the login Identity UI template file, but I wanted to at least alert you to how you could customize the login facility by overriding the default functionality provided out of the box by Identity. Before we move on to how we are going to customize our login facility, let's prove that we are able to override Identity's default login functionality by customizing the login Identity UI template file that we have just added to our project. Note that the title for the login webpage is currently login. Let's make a small change to this line of code in the login Identity UI template file so that the title for the login webpage will no longer read as login, but will now read as log me in. And let's run the code. You can see that even though we have only made a tiny change to the login Identity UI template file, we have effectively written code to override the functionality provided out of the box for the relevant Identity UI template file. Note that if we remove the login Identity UI template from our project, the default functionality shipped with the Microsoft.ASP.NET Core.Identity.UI package would run when we click the login menu item and log into the system. So we are going to create our custom login facility in 6 stages. Let's create the _UI login partial view. Let's update the login menu. Let's create the login model class. Let's create the login form. Let's create the UserAuthController class. Let's write the jQuery and AJAX client-side code. So we are going to create our custom login functionality in 6 stages. The first stage will involve implementing the HTML5 and Bootstrap code within a partial view we'll name _user_login_partial. This will involve implementing the code for the modal dialog box that will contain the login form. The second stage involves implementing the code to present the user with the login dialog when the user clicks the Login main menu option. The third stage will involve creating a login model, which will encapsulate the login-related data that will be passed between client and server during the login process. Note that as well as the email, password, and Remember Me properties, a property used for storing error status output will also be included in the login model. Once we have created the login model, we'll implement the fourth stage. The fourth stage will involve adding the login form code within the _user_login_partial view and wiring up the fields created in the login form to the relevant public properties contained within the login model. In the fifth stage, we'll create a new controller class and implement the code for authenticating the user's credentials that will be submitted to the server through our custom client-side login facility. We'll use Identity's built-in class named SignInManager to authenticate the user's credentials. In the sixth and final stage, we'll write the client-side jQuery and AJAX code to interact with the server-side code encapsulated within the relevant controller class. So let's create the partial view that will encapsulate the code for our modal login dialog. Let's right-click the shared folder in our default area. Let's select Add. And from the dialog box presented to us, let's select the list item labeled razorview-empty. Let's name our new razorview file _user_login_partial. Let's click the Add button. So we are going to use Bootstrap version 4 to implement code for our login model dialog. So we don't need to write the Bootstrap code from scratch. Let's find template code for a modal dialog implemented with the assistance of Bootstrap 4. Let's type in Bootstrap 4 modal into our search engines. We can click this link here to navigate us to the relevant web page where we'll find the template code we can use to implement our modal dialog. We can actually test the code on this web page to see if this is the front-end functionality we want for our modal dialog. Great, I think that will do. Let's copy this code to our clipboards. Let's paste it into our new partial view that we named _user_login_partial. So the next step is we must cut the parent div element here, and don't forget to remove the closing div tag. And then let's paste the div element that we have saved to our clipboards into the index view contained within our home folder in the default area. Then let's write code to close the relevant div tag. Let's set the ID attribute for this div tag to user_login_modal. Then let's write code to render the _user_login_partial view, which contains the modal dialog code within the div element that we have just pasted into our index view. You'll see later, when we implement our asynchronous code, why we are writing the code in this way. Very basically, it is so that we can target this div element in order to replace the contents contained within the div element with HTML returned from the server after the user has attempted to log into the system. So we will be able to update the contents of this div element asynchronously through the use of jQuery code. We'll see the details of this later in the tutorial. So let's open the login partial view from within the shared directory within the default area. This file contains code that denotes the login menu item, which is displayed in the main menu of our web application. So in order to wire up the modal dialog functionality, as it were, to the login anchor tag that denotes the login menu item, let's add an attribute named data-toggle, and let's set its value to modal. Let's then add another attribute named data-target and set its value to the ID of the modal dialog we wish to show to the user when the relevant login menu item is clicked. So let's set the value for the data-target attribute to #user-login-modal. User-login-modal is of course the ID value assigned to the bootstrap modal dialog we want to invoke when the login menu item is clicked. So, our modal dialog is now presented to us when we click the login menu item. Great! Let's create the LoginModel class. Once we have created our LoginModel class, we'll wire up the public properties within our LoginModel class to the fields within our login form. So to create our new LoginModel class, let's right-click on the Models folder, and let's select Add, and then Class. Let's give this class the name of LoginModel. Let's add a public string property named email. Let's add another public string property and let's name this property password. Let's add a public property of type Boolean and to name this property remember me. The last property we need to add is a public string property named logininvalid. You'll see the significance of this property later in the tutorial. So let's add the appropriate attributes for field validation and field labeling. For more information on applying these form-related attributes to model classes, please view the 14th part of this course. A link to this video is available below in the description. Note that the data type attribute declared against the password property will ensure that its corresponding input field will have its type attribute set to password. This means that when the user enters the user's password, that the entered characters will be appropriately masked. The email address attribute declared against the email property ensures that input entered into the corresponding email field is entered as a valid email address. Let's create the login form. So let's write the code that will denote our login form in our _user_login partial view. So let's open the _user_login partial view. To wire up the login model to the login form, we first need to strongly type our _user_login partial view by appropriately using the model directive at the top of our code like this. So to do this, we simply type @ followed by model followed by techtree MVC web application.models.loginModel at the top of our code. So now let's include a form tag within our modal dialog code. This form will contain input fields that will be used for entering user credentials before logging onto the system. Note, however, that the first field we are adding to our form is a hidden text field which is wired up to the logininvalid public property of our LoginModel class. This hidden field will be used to store output from the server and will contain status information indicating the success or failure of a user's login attempt. Let's include a text input field, which denotes a field representing the user's email address. Note, a valid email address must be entered into this field as the user's unique username. Let's include a password field, which obviously denotes a field into which a user can enter the user's password. Note that we are appropriately wiring up each field to its corresponding property in the LoginModel class by appropriately applying the ASP-4 helper tag. Note that I'm not going to explain the details of the Bootstrap classes that we are including in our code for layout and styling purposes. I'll include links to content on Bootstrap below in the description under the additional information section. If you don't want to follow along with this part of the tutorial, you can copy and paste the code from GitHub. A link to the relevant GitHub web pages have been included below in the description. The last field to include in this login dialog is a checkbox denoting a Remember Me field. Clicking the Remember Me checkbox tells the browser to save a cookie so that if a user closes out the window for the site without signing out, the next time the user invokes the application, the user will be signed back into the application automatically. Right, let's run the code to see how our login dialog form looks. Great, but the current position where our login dialog is spawning is not ideal. So let's add a Bootstrap class named modal-dialog-centered to the relevant div element within the _user login partial view, so that our login dialog spawns in the center of our screens. Let's test this. Great. Let's include form validation related code for our login form. Let's include a div element within our form element that contains the ASP-validation-summary helper tag attribute set to model only. Let's include a span element under each of the relevant form fields and appropriately include the ASP-validation-4 tag helper attribute in each of the relevant span elements. These span elements denote form field validation related exception messages that will be displayed under each relevant form field when appropriate. Let's give the button that our users will click to log into the application a name of login. And for good measure, let's give the login button an ID attribute and set this attribute's value to login. Right, let's see what our form looks like. Great. Let's create the UserAuthController class. Let's add a new controller class to our project in the default area. So let's right-click the controllers folder, click Add, Controller. Let's select MVC controller-empty from this list. Let's give our controller the name UserAuthController and click the Add button. As you have probably guessed, we are going to add code to this new controller class for authenticating and logging our users into the system. We'll also add code responsible for logging our users out of the system to this class. So you can see that this is not just a plain old C# class, and that code that makes this class an MVC controller class has been automatically included in our controller class. You can see here that our class is inheriting from the base class named controller. The controller class, from which our UserAuthController class is inheriting, is a member of the Microsoft.ASP.NET-Core.MVC namespace. If we comment out the using directive that references the Microsoft.ASP.NET-Core.MVC namespace, you can see we have several red squiggly lines in our UserAuthController class, which reveals to us how important the functionality contained within the Microsoft.ASP.NET Core.MVC namespace for our MVC controller functionality is. Right, so we don't need the index action method that has automatically been added to our controller class, so let's delete the index action method. Let's add 3 private read-only member variables to our controller class. Let's add a private read-only member variable, which is of the generic type userManager that is strongly typed with our application user type. Let's name this variable _userManager. We must include a using directive to reference the Microsoft.ASP.NET Core.Identity namespace. We must also include a using directive to reference the tech tree MVC web application.data namespace because our application user class is a member of this namespace. Remember, the application user type inherits from the identity user type, which is a type that is built into identity. Note that through EF Core, the application user type is mapped to the underlying ASP.NET user's identity database table. Note that we won't need to use the user manager type for our login functionality in this tutorial, but the user manager type will later be used to implement user registration functionality. We'll implement the code for this in an upcoming tutorial. The type that we'll use to log a user into our system is named sign-in-manager. Let's create a read-only member variable of type sign-in-manager, and let's strongly type the sign-in-manager type with our application user type. Let's name our variable _sign-in-manager. Lastly, let's create a read-only member variable to store our EF Core database context object. Let's name the variable that will reference the EF Core database context object _context. The next step is to create a constructor for our UserAuthController class. So let's create a parameterized constructor that contains 3 parameters. The first parameter is of type ApplicationDBContext. The second parameter is of type userManager, that is strongly typed as application user. The third parameter is of type sign-in-manager and is strongly typed as application user. So let's now appropriately set our read-only member variables to their appropriate counterpart parameter values within the constructor that we have just created. It is important to note that we don't have to write calling code to pass in the arguments to the parameters contained within the constructor of the UserAuthController class. The appropriate objects will be passed into this constructor through dependency injection. Dependency injection is built into the MVC core framework. Relevant code within the configure services method in the startup.cs class is responsible for adding the appropriate services to the dependency injection system. I won't go into more detail regarding dependency injection, but I've included appropriate links under the additional information section in the description if you'd like to read more about dependency injection. So we are now going to create 2 action methods. Very basically, the first action method will contain functionality that logs the user into the system. The second action method we'll create will contain functionality that logs the user out of the system. So let's create a public asynchronous method named login that returns a task object that is strongly typed with the iActionResult type. The iActionResult type is a member of the Microsoft.ASP.NET Core.MVC namespace. For details on the iActionResult type, I've included appropriate links below in the description under the additional information section. If you'd like to learn more about async, await, and task, I've included an appropriate link below in the description to a video series created by this channel on C# asynchronous programming. Our login method contains 1 parameter of our LoginModel type. This is our user-defined type representing the login model. So the LoginModel object, obviously derived from the LoginModel class, passed into this method, will contain the user's input, i.e. the user's login credentials, that will be entered into our login form through the user's browser. Let's first set the login invalid property on the LoginModel object to a string value of true. This property value will be used in the client-side jQuery code that we'll implement in a bit to assess whether a login attempt was successful or unsuccessful. We'll see the significance of this property a little bit later when we write our jQuery code that asynchronously calls this login method. The next step is that we need to assess if the user's input is valid. For example, has the user entered a correctly formatted email address for the email field? Has the user left a field blank, etc.? This can be done through the MVC framework by checking the isValid property on the model state object. Basically, the model state.isValid property is an inbuilt property of ASP.NET Core MVC, which verifies two things. Number one, whether the form values are bound to the appropriate model. Number two, all the validations specified inside the relevant model class through the use of data annotations have been validated. So if the model state.isValid property is true, we can attempt to log the user into the system. So to do this, we can use the _signin manager object's password signin async method to verify the user's credentials, like this. We can then return a value from the password signin async method and assign it to a variable named result, which contains information about the success or failure of the relevant login attempt. So we can check the succeeded flag on the result object like this. So if the user has successfully been logged into the system, let's set the login invalid property on the LoginModel object to an empty string. You'll see later how this value is used on the client as an indicator as to whether the user's login attempt has succeeded or failed. So if the user is not authenticated, we can write code to add an error message to the model state object, which will result in an error message being displayed to the user. And the login dialog will stay on the screen so that the user can make another attempt to log into the system. So note that the first argument is an empty string. This simply means that the error message passed into the second parameter does not pertain to a particular field on our login form. So the relevant error message will be displayed where we have coded our summary error messages to be displayed on the login dialog. This will become clear to you when we test the code a bit later. The next step is to return the code contained in the _user login partial view back to the client. Note that if the user's login attempt has failed, our LoginModel dialog, which has been coded in the _user login partial view, will be displayed to the user again and will contain feedback pertaining to the reasons why the user's login attempt failed. So this will provide the user with the means to make another attempt at logging onto the system. Let's declare the necessary attributes against our login method. So the allow anonymous attribute means that this method is publicly accessible, i.e. no security restrictions are imposed on this method. So you don't need special authorization privileges to access this method. This method is run in response to a HTTP post request, so let's declare the HTTP post attribute against this login method. And the last attribute we need to declare against the login action method is named validate anti-forgery token. The validate anti-forgery token attribute denotes what is known as an action filter. Requests made to action methods that have this filter applied are blocked unless the request includes a valid anti-forgery token. It is important to note that this feature prevents cross-site request forgeries. Basically, preventing cross-site request forgeries is about making sure that a form post comes from an appropriate form. I've included links to information regarding the validate anti-forgery token attribute below in the description under the additional information section. Great, let's write the code for the logout method. Let's create a public asynchronous method named logout. The code for this method is very basic. The code involves a call to the relevant sign-in manager object's signout_async method. Note, our logout method contains one parameter. This parameter is an optional parameter. The fact that the parameter is optional can be easily identified by the fact that it is initialized to a default value. In this case, that default value is null. So if the calling code does not provide an argument when calling the logout method, the relevant parameter value will be null. So let's write an if statement that checks the relevant parameter value. If it is not null, we can return a value returned by the local redirect method and pass in the appropriate parameter value when calling the local redirect method. So this line of code will result in the client being redirected to a specified location, i.e. the location specified in the argument passed to the return URL parameter. Else, if no parameter value was passed into the logout method by calling code, we can return the result of the redirect to action method and pass the action name and the controller name relevant to the location where we wish the client's browser to be redirected. Let's declare the relevant attributes against our logout action method. So, that is our UserAuthController class completed for now. We can now use the code within this class to log a user into the system and log a user out of the system. Let's write the jQuery and AJAX client-side code. So let's write the client-side code to asynchronously submit data entered by the user into the login form to our server-side login action method that we included in our UserAuthController class. Our server-side code will either log the user into the system or deny the user's login attempt, based on the credentials submitted by the user through our login form. So let's add a JavaScript file to an appropriate folder in our project. Let's expand the www root directory. Let's right-click the JS folder. Let's click Add. Let's give our JavaScript file the name of userlogin.js. So as discussed, we are going to use jQuery code to implement the relevant asynchronous client-side login functionality. Let's use the $symbol preceding an anonymous function wrapped in brackets. Note the $symbol is an alias for jQuery. Let's wire up a click event to the login button that resides on our LoginModel dialog. Then let's create the appropriate event handler for the relevant button click event. So when a user clicks the login button on the LoginModel dialog, our event handler code will be fired. This is the method we are about to write to handle the click event on the login button. Let's prove this by including code to pop up an alert when the login button is clicked. Let's test that our event handler has been wired up to the click event of our login button. Okay, so I've forgotten something. Oh, we of course need to include a reference to our userlogin.js file within the appropriate view. So let's open the appropriate index view and appropriately include a reference to our userlogin.js file, like this. Let's test our button click event handler. Great! Let's remove the alert code and write the logic for the login button click event handler function. Let's create a variable named URL and set its value to the location of our login action method. For security reasons, we are going to have to submit what is known as an anti-forgery token along with our user's login credentials to our login method. So let's write code to retrieve the value from a hidden text field named __request verification token and assign the retrieved value to a variable named anti-forgery token. The hidden input field named __request verification token is a hidden text box that is automatically included in our code by MVC. On the server side, remember we declared the validate anti-forgery token attribute against the login action method and later the logout method. When we added this attribute to the relevant action methods, we discussed that this filter attribute needs to be added like this so as to prevent cross-site request forgeries. So the anti-forgery token that we need to submit to the relevant action methods, i.e. the login and logout action methods, is stored in a hidden input field named __request verification token. So we must include the anti-forgery token value along with the login form field values in the object that will be passed to the server side, i.e. submitted to the server side, when a user clicks the login button. Let's test that we are retrieving the anti-forgery token value correctly. So let's write code to display the anti-forgery token in an alert. And there it is, great. So let's remove the alert code. Let's appropriately create variables to store the values that will be entered into the relevant fields by our users. Let's create an object variable named userInput and set it to an anonymous JavaScript object that encapsulates the user's input as well as the anti-forgery token. Great, so we can now write the AJAX code using jQuery that asynchronously posts the user's input and the anti-forgery token to the server. So we can do this by first writing the dollar symbol, this is the symbol representing jQuery, followed by a dot, then the AJAX method. Then we can pass an appropriate anonymous JavaScript object containing option settings to the AJAX method. This anonymous JavaScript object will contain AJAX-related settings, which will include a function to handle an event triggered when the AJAX operation completes successfully. So, a callback function that we define will be called when the AJAX operation completes successfully. We will also include a function in the relevant anonymous JavaScript object that will be triggered in the event that the AJAX operation does not complete successfully. So, let's set the type of our request to post by appropriately setting a property named type. Let's set a property named URL to the location of our login action method. Remember, we set our URL variable to userauth, the name of our controller, /login, the name of our action method. Then we set the property named data to the object we coded to encapsulate the user's input and the anti-forgery token. So this object will be passed to the login action method when the user clicks the login button. Note that the login action method contains a parameter of type LoginModel. The object we are submitting from our jQuery client code contains properties that correspond to the properties contained within our LoginModel type. The only value that is not contained within our LoginModel class, but is contained within the anonymous JavaScript object assigned to the user input variable, is the property used for storing the anti-forgery token. This value is handled by the action filter denoted by the validate anti-forgery token attribute that has been declared against the relevant action methods. So let's include a property named success. We can assign an anonymous function to the success property. This function will run when our post request to the server executes successfully. So this function is a callback method and allows the server to pass data to the client when the relevant post request has completed successfully. So if you'll recall, we are returning the _user login partial view from the login action method once the login action method has run successfully. So the front-end code encapsulated in the _user login partial view is passed as an argument to the data parameter from the server side once the login action method has completed successfully. So this AJAX operation allows us to update only a portion of the HTML rendered in the client's browser window, asynchronously, rather than needing to update the entire HTML document within the browser window. So only a portion of the HTML rendered within the browser window needs to be refreshed after a round trip to the server has completed, and we can avoid rendering the entire HTML document within the client's browser window. This provides the user with a far better user experience, UX. So, we only want to render what's in the _user login partial view, which of course contains the code for our LoginModel dialog when there are issues with the user's login attempt. Firstly, let's write code to parse the HTML code stored within the data variable, i.e., data returned from the server. So now we can use a method named find, a jQuery method, to find a specific text field contained within the relevant parsed HTML. Remember, this is the HTML contained within our partial view. So we can write code to find the login invalid hidden text field like this. Remember, the login invalid hidden text field is updated on the server when the login attempt fails. It is initialized with a literal string value of true unless the login attempt succeeds, whereby the hidden text field is set to an empty string. So, if the login invalid hidden text field is set to true, this means there were issues with the user's login attempt. So we can set the result of this expression, which checks the value of the login invalid hidden text field, to a variable named hasErrors. If there were issues with the user's login attempt, the hasErrors variable will be set to a Boolean value of true. This is because the expression evaluates whether the login invalid hidden text field is equal to the literal string text true. So if the hasErrors variable is set to true, we want to display the login dialog to the user again so that the user can make another attempt at logging into the system. So we can achieve this in code by using the HTML jQuery method to replace the content in the specified div element with the HTML content passed from the server through the data parameter. Else, if the has error variable has been set to false, this means that the user's login attempt was successful. In this case, where the user's login attempt was successful, we can implement code to redirect the user to an appropriate view, which is the home index view. We can then set the error property in our AJAX settings anonymous JavaScript object to a function that will handle a case where the post request fails. A failure could occur, for example, if a 404 HTTP exception is flagged due to the AJAX method attempting to post to an action method that does not exist, or a 500 HTTP status exception is flagged because of an unhandled exception occurring on the server side, etc. So in this case, at least for now, let's write code to simply log the relevant exception messages to the web browser's console window. Let's test to see if we can now log into the system by submitting our admin account credentials through our new LoginModel Dialog functionality. Great, so that is basically working. We have successfully been authenticated. You can see that a welcome message is outputted to the screen in the menu bar, and we now have access to the admin menu. We are now able to perform administrative operations through our web application. So we have just demonstrated an example of an administrator successfully logging into the system. Let's see what happens if a user enters incorrect credentials. Great! Let's test the field validation code for our login form. Let's click the login button without entering any data into the login form. Great, so the form field validation seems to be working when we try to submit our data to the server. But our form validation is not being executed on the client through client-side unobtrusive validation. So our form field validation functionality is working, but it isn't optimal. We want to provide our users with the best user experience possible. And at the moment, our login dialog is not as responsive as it could be. So we can include unobtrusive client-side validation to ensure that our login dialog is more responsive. To achieve this, we first need to add code that renders the underscore validation script's partial view within the page where our login functionality resides. So we need to render the underscore validation script's partial view within the home index view. This is where we are rendering our LoginModel dialog. We can achieve this through this line of code. It contains two references to jQuery files. These jQuery files contain functionality for performing form field validation on the client. Note that in order to make our unobtrusive validation code work after the LoginModel dialog is refreshed with data returned from the server, i.e., as a result of a failed login attempt, code to reinitialize the unobtrusive validation functionality needs to be run. So let's include the necessary code that will allow client-side unobtrusive validation to work after a login attempt fails. Let's test the code. Great! So, we have leveraged the power of identity for our login functionality, but we have also managed to customize the login experience for our users. Excellent! Just to summarize, in this video, we created the _user login partial view to encapsulate the code for our login modal dialog. We updated the login menu item to invoke our login modal dialog when the login menu item is clicked by the user. We created the login model class to encapsulate the data passed between our login modal dialog and our server-side controller code. We created a login form within our login modal dialog and wired up the login form fields to the public properties in our login model class. We created the UserAuthController controller class and added server-side code that leverages identity to log a user into the system. And we also created code to log a user out of the system. We wrote jQuery code and leveraged the power of AJAX to send data containing a user's login credentials to the server asynchronously. We wrote code to display our login dialog to the user after a failed login attempt, so that the login form presents feedback from the server to the user as to why the user's login attempt failed. The asynchronous nature of our code made it possible to display our login form containing feedback information from the server to the user without refreshing the entire screen. Our asynchronous code only refreshes the portion of the screen relevant to the login modal dialog. Excellent. Okay, so there's a lot of information to take in, I know. If you have managed to get through this tutorial, congratulate yourself by doing whatever it is you do to congratulate yourself. For content like this and much more, please consider subscribing. And please ring the bell so that you'll be notified of future content. If you like this video, please give it a thumbs up. And please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will be greatly appreciated. I really enjoy reading your comments, so please feel free to engage with me in the comments section. The latest code can be found on GitHub. A link to the relevant repository can be found below in the description. Thank you, and take care.